All right, today's lesson is going to be about solution concentration, and specifically a unit called molarity. All right, so the first thing, when we just think to ourselves, what is solution concentration? Well, basically, what it is, it's going to be a relative measure of the amount of dissolved solute, really compared to the amount of solvent that's present. Okay, and so like let me give you a couple of examples here for this second part where it says what's the difference between dilute and concentrated. Um, Dilute means that it's really watered down. You don't have much of the dissolved solute in it. For example, let's say you're having a Kool-Aid stand, out at the end of your driveway, all right, and you get one of those big 5-gallon, like the Gatorade jugs you see that has the little spigot, the little spout on the bottom. And let's say you're going to sell this Kool-Aid, but you want to make a lot of money. And so you take the one little packet of Kool-Aid and the couple of cups of sugar, and you take your garden hose and you fill that thing up to 5 gallons. I mean, is that Kool-Aid? Well, I guess technically it is, but it's not going to taste real good. It's going to taste mostly like water because you have a ton of solvent, a ton of water, and not a lot of the solute in there. Okay, so that would be dilute. Concentrated is the exact opposite, where you have a lot more solute than you normally would. So, like, say for example, you're going to have a Kool-Aid stand, and in each glass you're going to put an individual packet of the Kool-Aid stuff, and it's going to be real strong. You're going to have a lot of flavor because usually, that's going to make a couple of quarts. It's going to make a big pitcher of it. So, yeah, that's kind of the difference between dilute and concentrated. And so, in chemistry, we need a way to kind of indicate or quantify how much solute is in there. And so one of the units we use is molarity. And so this is molarity. You notice you abbreviate with a capital M. And so I don't know if you guys recall or not, but in class we've seen some of these things before. This written like 6M HCl, 6 molar hydrochloric, or 1 molar hydrochloric. Up till now, probably didn't have a lot of meaning to you. But now those numbers are going to have meaning. It tells you basically how much of the acid is dissolved in water. And this is the formula for molarity. Molarity is moles of solute per liter of solution, or molarity is moles per liter. Okay, so it tells you how much dissolved substance in which quantity of the solvent. Well, the entire solution, I guess, but the solvent is going to make up the largest volume of that. Okay, easiest way for me to do this is just to work through a few problems and then give you guys some opportunity to practice this. So here it's asking what's the molarity of a solution if I have 5.85 grams of potassium iodide dissolved in enough water to make 0.125 liters of solution. Well, you're going to recall from the previous page, molarity is moles over liters. And so we're trying to solve for the molarity. We know the liters, right? We don't know the moles, but we do know grams. Well, guess what? If you know grams, you can solve moles. You've been doing this forever. 5.85 grams of Ki, and I want to make this into moles. Well, moles need to go on top. 1 mole of potassium iodide should weigh 166 grams of potassium iodide. Grams cancel. I divide, and this is going to give me 0.0352 moles. 3 sig figs because of those three. Now all I do, I know the moles, I know the liters, I just need to divide 0.0352 moles divided by 0.125. Oops, that should be a 5, not an L. 5 liters. And when you divide that with sig figs, should be 0.260 molar is the concentration of your solution. Okay. Next one, what's the molarity of a solution? I have 0.09 moles of sodium sulfate dissolved in 12 mils. Once again, molarity is moles over liters. So I want to know the molarity. I do know the moles this time. It's 0.09 moles. Okay. And then I want to convert this. Notice these are milliliters. It has to be liters. So if I want to convert milliliters to liters, you guys realize 12 milliliters, well, there are 1,000 milliliters in every 1 liter. Mills cancel, you divide. So what it essentially does is move the decimal 3 places to the left. So this is going to be 0.0120 liters. That's 12 mils. That's the same thing. 0.0120 liters. When you do that, your calculator is going to spit out 7.5. But notice there's only one sig fig here, so you need to call that 8 molar. All right. Last one. Let's say I want to make 25 mils of a 0.3 molar solution of sodium hydroxide. How could I do that? Well, once again, it's the same formula. Molarity is moles per liter. I do know the molarity this time, 0.30 molar. I do not know the quantity of the sodium hydroxide. And then once again, when you convert milliliters to liters, you don't have to show the work. I understand you're going to figure out real quick. You move the decimal 3 to the left. So 0.0250 liters. Okay, to solve this, I'm going to multiply, right? I'm going to cross multiply this. And so when I do that, this ends up being, what is it? I think if you cross multiply that, it ends up being 0.0075 moles is what you get of NaOH. Now, here's the thing. Me telling you have 0.0075 moles of sodium hydroxide doesn't do you a whole heck of a lot of good because you measure it with a balance. You can't measure moles with a scoop, but we can do this with a balance. So we need to find out its molar mass. Well, every mole of sodium hydroxide weighs 40 grams. Okay, and so what I'm going to do is I'm going to multiply 0.0075 times 40, and what you're going to end up with is you end up with 0.30 grams of sodium hydroxide, and then I would just dilute to the 25 mils total volume. Okay, so that's the mass of sodium hydroxide you'd weigh out. You'd put it in a graduated cylinder and dilute it up to the total volume of that solution is 25 mils. That's basically how it goes. These are very, very repetitive. What I'm going to do is I'm going to give you a few of these to practice, and I want you to practice them, and I'll give you the key then tomorrow. All right?